So we're going to be looking at formal charge, and essentially you're going to see a structure. You're going to figure out whether or not there is a charge indicating on a particular atom. And if so, go ahead and identify any of the formal charges in any of these structures below. So the way to do that is you want to know where the atoms are located on the periodic table. So you may want to have your periodic table handy. And essentially what I did here is a periodic table. The numbers on top indicate the number of valence electrons associated with that particular atom. Take, for example, carbon. Carbon likes to have its 4 valence electrons for it to be neutral. Anything above or below that number will indicate that it has a charge, either positive or negative. So with that said, let's look at our first structure. We have aluminum in the center, and it's surrounded by hydrogens. So our hydrogens look okay because our hydrogen has 1, as indicated here, correct? Has 1. So we're okay with that. Let's look for aluminum. Aluminum is located on... So in this particular case, aluminum is right here. Let me get that here. There's aluminum. So aluminum has likes to have 3 valence electrons. So let's see if we have that. And in this case, we have 4. And because we have 4, it's going to bear a charge. It has an extra electron, so we're going to put as indicating the charge as negative. Why? Because it has that extra electron. Now let's look at our number 2. Hydrogens look okay. But let's double check that oxygen. So if I were to count the individual electrons, remember that each bond, think of it as a tip that has 1 electron. So the ends of those bonds counts as 1. So 1, 2, 3, 4, and 5. Now, where is our oxygen? Our oxygen is right here, and oxygen prefers 6 valence electrons, and we have 5. Therefore, the oxygen is going to bear a charge, and in this case, it'll be positive. It's missing 1 electron, right? 5 needs 6 to be neutral. All right, so our hydrogens look okay in this next one, but let's count the valence electrons on the nitrogen. 1, 2, 3, 4, 5, 6. And nitrogen likes to have how many? 5 with 6. That's going to bear a negative charge. Perfect. So go ahead and try to do these next number 4, 5, and 6 on your own based on these rules, and then double check to see if you got them right. So let's go ahead and look at oxygen. Let's count 1, 2, 3, 4, 5, 5. And we just looked at it. Oxygen likes to have 6 right here, 6, and we have 5, so we're missing 1. So it's going to have a positive charge. This is an interesting one. This is a carbon with a lone pair. It's something that looks a little unfamiliar right now, but you'll see in organic chemistry, you're going to see this come up more often. So we don't violate the octet rule, right? 1, 2, 3, 4, 5, 6, 7, 8. Now let's count individually. 1, 2, 3, 4, 5. So that is going to have a negative charge. So known as carbocation, carbocation with a positive charge. All right, so now we have the same thing, except we don't have that lone pair on that carbon. So if we were to count the number of electrons, we'll only have 3. So if we only have 3, we're missing 1. So it'll be a positive charge. Carbocation. All right. Hydrogens look okay. This carbon looks okay. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, 7, 8. That carbon looks okay. Now let's go ahead and look at our oxygen. 1, 2, 3, 4, 5. Now we said oxygen likes to have 6 to be neutral. It's missing 1. So positive. Aluminum. What did we say about aluminum? It's on group 3. Yeah, there it is. It's on group 3. 3 valence electrons. 1, 2, 3, 4 has 1 extra. So that's going to have a negative charge. Let's see if everything else looks okay. Chlorine. Let's count. 1, 2, 3, 4, 5, 6, 7. All right. So I locate chlorine. And it's right here. 7 valence electrons. So let's go back. So these chlorines are okay because they have 7. This one's okay, this one's okay, this is okay, this is okay. Now let's look at this one. 1, 2, 3, 4, 5, 6. All right, so this one's missing an electron. So that is going to have a charge as well. So this structure down here had two charges. And interesting little side note is that they are opposite. Opposite charges attract each other. All right, let's look at our carbons. This carbon looks happy. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. This carbon looks happy. Let's look at our oxygens. 1, 2, 3, 4, 5, 6, 7. We said that oxygen likes to have 6 valence electrons. It has 7, so it has an extra charge in there. Let's look at this one. 1, 2, 3, 4, 5, 6. Oh, this one was supposed to have this. All right, so now let's look. Count again. 1, 2, 3, 4, 5, 6. Perfect. It's neutral. There's no charge on that oxygen. Is there anything else that sticks out in here? We do see a nitrogen, so we have to kind of inspect that one. See a nitrogen. So let's see. Let's count. 1, 2, 3, 4, 5, 6, 7, 8. It has an octet. It's not violating the octet rule. Now let's count individual electrons. 1, 2, 3, 4. All right. Let's locate our nitrogen. 5. So it's missing 1 electron. So then this will have a positive charge. All right. So that is pretty much how you take a structure and figure out whether or not there is a charge on any particular atom. Make sure that you have your periodic table handy until you memorize the number of valence electrons on these atoms. For organic chemistry, you're mainly going to be working on this side of the periodic table, so it'll be good to kind of have these memorized. And within time, you'll have it memorized due to doing a lot of structures.